Usually when we think about the internet, we imagine this invisible magical realm, like a wireless ether where emails and streaming movies just sort of float through the air right to your devices.
Right, yeah, the famous cloud. I mean, it feels completely weightless.
Exactly. But
Yeah.
today we are going to ground that cloud. Welcome to today's deep dive.
Yeah, glad to be here.
So our mission for you today is to decode a really highly technical product page from HDTV Supply. Specifically, we are looking at the Avenview FO-MMD-SC-SC-50, which is a 50/125 duplex fiber optic patch cable.
It is quite a mouthful.
It really is. I mean, it sounds like just a random 165-foot piece of wire, right? Okay.
Right.
But this specific cable is the physical, laser-optimized backbone of our modern high-speed world. It's used in everything from military setups to massive telecommunication networks. Okay, let's unpack this intimidating name into some digestible parts.
Well, it is quite the alphabet soup. But every single letter and number is a highly engineered specification. So let's start with the 5125 Duplex Multimode 10 gigabit OM3. That basically describes the core of the cable itself.
Right, and the term multi-mode really stood out to me, because I know a simplex cable is basically just a one-way street for data.
Exactly.
So multi-mode must be like a multi-lane superhighway. But how exactly does a microscopic glass tube have lanes?
What's fascinating here is the physical mechanics of it. The 50 in that name stands for a 50-micron glass core.
Which is tiny, right?
Oh, yeah. Thinner than a human hair. Multi-mode means the core is just wide enough that we can shoot multiple light pulses into it at slightly different angles.
Oh, wow.
Yeah. And these light waves bounce off the 125-micron outer layer of the glass, which is called the cladding. They bounce in zigzag patterns.
So because they bounce at different angles, they create separate paths.
Right, separate paths or modes, and that allows multiple streams of data to travel simultaneously.
Ah, so the lanes aren't side by side. They're literally bouncing at different angles inside the exact same microscopic pipe.
You got it.
And the source mentions it uses LED and VCSE lasers. What exactly is a VCSE?
So VCSEL stands for Vertical Cavity Surface Emitting Laser. You see older cables used basic LEDs, which are a bit like a flashlight.
The light sort of scatters everywhere.
Exactly. But a VCSEL is a highly focused, extremely fast laser that can pulse billions of times per second.
Billions?
Yeah, billions. That precise rapid-fire pulsing is what allows this specific OM3-rated cable to push a massive 10 gigabits of data per second over those bouncing light paths.
That is incredible, but I mean, transferring light at 10 gigabit speeds is totally useless if the physical connection at either end of this highway is flawed.
Absolutely.
So how does this thing actually plug in without breaking the light?
That brings us to the SC to SC part of the name. Those are the connectors at each end. And inside the connector, there is a 2.5 millimeter ceramic ferrule.
A ferrule?
Yeah, it's a little cylindrical housing that perfectly holds the glass fiber.
Oh, why ceramic, though? Why not just use plastic or metal?
Well, ceramic is crucial because it doesn't warp. You know, metal expands and contracts with temperature changes and plastic degrades.
Oh, I see. So if it gets hot in the server room?
Right. If the connector shifts even a fraction of a hair due to heat, your light wave hits a wall.
Wow.
Ceramic ensures that microscopic alignment stays absolutely rigid.
Okay, I see the logic there, but I have to admit I'm a bit confused by the outer design. The source describes these SC connectors as having a simple push-pull snap and latch.
Do you? Yeah.
But if I'm building a military network or critical wide area network, why trust 10 gigs of data to something that just snaps in like a piece of plastic?
That's a fair question.
Like, why not use a heavy-duty twist lock connector like that ST type the source mentions?
If we connect this to the bigger picture, it's all about real estate. Modern server rooms aren't hooking up one or two of these. They are routing thousands.
Right there, absolutely packed.
Exactly, and SC connectors are explicitly designed for high-density environments. A twist-style ST connector requires your fingers to physically get around the entire barrel to twist and lock it.
Which you obviously can't do if there are 50 cables packed into 1 square inch.
Exactly. The square push-pull SC connector lets you pack them incredibly tightly into a patch panel. You just push it in until it clicks.
Just a quick snap.
Yep, and despite being a quick snap and stop, these are rated for 1,000 mating cycles.
Wait, 1,000. So you can plug and unplug them 1,000 times.
1,000 times with only a 0.25 decibel insertion loss.
Decibels, like sound.
Well, in optical physics, decibels measure signal loss. A 0.25 decibel loss means an incredibly tiny fraction of the light escapes when the two ends meet.
So it's an almost perfect seal.
It really is.
So what does this all mean for the person actually buying it?
It really comes down to practical, reliable infrastructure. At $206.60, you are getting a fully tested, pre-terminated cable.
Meaning you don't have to put the ends on yourself?
Right, which means you aren't paying a highly specialized technician to sit in a server room, perfectly slicing and gluing microscopic glass fibers on site.
Which would cost a fortune in labor.
A massive fortune. Plus, it features an OFNR jacket.
And that stands for?
Optical Fiber Non-Conductive Riser. It basically means the outer plastic is specially formulated so that if a fire breaks out, the flames won't travel up the cable shaft to other floors.
Ah, plug-and-play solution that is fire-safe and perfectly aligned straight out of the box.
Exactly.
You know, it completely changes how you look at the physical world of data.
Yeah.
We spend so much time worrying about software bugs or hackers.
Yet,
Consider this. The entirety of human knowledge, our financial markets, our communication,
everything.
yeah, they all ultimately depend on the mechanical tolerance of a tiny ceramic cylinder. If that microscopic piece of earth shifts even a hair, the right stops and the digital world goes dark.
It's definitely something to think about next time you hit send.